annulus is the area between two concentric circles. So they're talking about this part here, the shaded part. So the radius of the larger circle is twice the radius of the smaller circle. And if we know that the area of the annulus is 12 pi, we want to find the radius of each circle. So how you find the area of this is you would take the area of the whole large circle and you would subtract the area of the small circle, and you'd be left with the area of the annulus. So that's the process that we're going to go through. So oops. Okay. So I know that the area of the annulus is 12 pi, so I'm going to substitute that in here. The circle formula for area is pi r squared. So for the big circle, it would be pi, and my radius is 2r. So 2r squared. Minus for my small circle, it's pi, and my radius is r, so r squared. And now we're going to solve for r. So what's going to happen is I have a 12 pi is equal to a 2r squared is going to be a 4r squared, and I'm going to put the pi on the end. And same thing here, I'm going to put the pi on the end. So I do wind up with 12 pi. These are like terms of 4r squared pi minus an r squared pi is a 3r squared pi. Now if I divide both sides by pi, the pi's cancel out. So I'm just left with a 12 is equal to a 3r squared. Dividing both sides by 3, I wind up with 4 is equal to r squared. And then taking the square root of both sides, I cannot have my radius be negative, so the only possible solution here is that my radius is positive 2. So that would be the radius of the small circle, but we want to find the radius of each circle. So the radius of my big circle then would be 2 times 2, which is 4. And that's it. All right, the next one, I have ED being the diameter, and it's perpendicular to chord CB. So what that means, if we know that the radius or diameter is perpendicular to a chord, then that chord is bisected. DF is length 8, and FE is length 2. That covers the whole span of the diameter. So the diameter is 10, which means the radius is half of that, which is 5. So DA is 5 and AE is 5. And if FE was 2, that would make AF 3. They want us to find AC, which is a radius. The radius is 5, so AC is 5. They also want us to find BC. Well, if we look at this triangle here, this is a right triangle, and it's a 3, 4, 5 right triangle, and that chord is bisected, so this is also 4, which means BC is going to be 8. Okay, so letter A is done. Now it says to find the measure of angle CAB. In order to do that, I'm going to find CAF, and then I'm going to multiply by 2, because I know that this angle is congruent to this angle since this is an isosceles triangle. In an isosceles triangle, the altitude bisects the angle. So to find angle X, I have a right triangle. I have the opposite side of 4, a hypotenuse of 5. So let's use inverse sine. Typing this into my calculator, I'm going to have to round. I'm going to round to the nearest hundredth. I get a 53.13. But remember, that was just the measure of angle CAF, and I want the measure of angle CAB. So to find the measure of angle CAB, I'm going to need to multiply this by 2. And I get 106.26 degrees. Now they want the arc length of CEB, which is the arc across from that 106.26 degree angle. So we're going to use that along with the arc length formula. So S stands for arc length, and that's going to equal our angle over 360 times 2 pi r. My radius, remember, was 5. And we're not going to be able to do exact because we already have our angle as rounded. So we're just going to type this into our calculator. So 106.26 divided by 360 times a 2 pi times 5. And I wind up with about a 9.27. centimeters as my arc length. Now they want the area of the sector for this. So what we're going to do is we're going to use this area of the sector formula in degrees. So that's 106.26 divided by 360 is equal to pi r, or sorry, not equal, sorry, times pi r squared. So I wind up with the area being approximately equal to, again, we're not going to be able to put it in exact format. So just typing this into my calculator, I wind up with about a 23.18. And then it says to find the area of the segment. So if I take the area of my sector and subtract the area of the whole triangle, which my height is 3 and my base is 8. So I'm going to do the area of my sector minus 1/2 times my base of 8 times my height of 3. So let's just write this. The area of the triangle comes out to be 12. So my area of my segment is going to be rounded because my area of my sector was rounded. It comes out to be 11.18. All right, moving on to the next problem. I want to find the measure of angle CAD. I'm going to label that as X. I have the arc length and I have the radius. Let's do it in degrees. So Using the arc length formula, I'm going to put the arc length in my formula. I don't know what the angle is. I'm going to find that. And then 2 pi r. So multiplying both sides by 360, I get that 360 gone on this side here, and I'm left with this. Dividing by 12, I would wind up with this. Dividing by 2, I wind up with this. And lastly, dividing by pi, I wind up with x is approximately equal to 47.75 degrees. Now they want us to find the area of the sector. So I'm going to use that 47.75 degrees. Whoops. And since that's a rounded degrees, I cannot put this in exact format. So I'm just going to type this all into my calculator. So 47.75 divided by 360 times a pi times a 12 squared. I get about a 60 units squared. Okay, so on to the next one. This one's a little bit tricky. So what we're going to do to find the area of this is we're actually going to find the area of my full circle, and I'm going to subtract the area of this segment and this segment, which those are going to be equal segments because these arc lengths here are equal, or those arc degrees are equal. So let's find the area of the full circle first. Actually, we can't. We need to find the radius. And how we're going to find the radius is we are going to use this triangle here. I'm going to pull that out. This arc is 60 degrees, which means the central angle is 60 degrees. This is 14 degrees, and that's going to be the same length as this part of my triangle. So this is 14 degrees. And then this is an isosceles triangle, because those two sides are the radius. So what that means is that if I split this down this, if I drew in the altitude, this turns this into a 30-degree angle, a 30-degree angle, and 60 and 60. And then it splits the space into 7 and 7. Using 30, 60, 90 rules, I have the side across from my 30-degree angle. To get from that to the hypotenuse, I multiply by 2. To get from that to my side across from my 60-degree angle, I multiply by root 3. And so actually, the radius of the circle is 14, which is nice. So now I can find the area of my full circle, which is going to be pi times 14 squared. And this comes out to be approximately 615.8 units squared. Okay. From there, I'm now going to look at this triangle, and I'm going to find the area of this segment. This triangle is going to have a 120-degree angle, and I'm going to draw that triangle outside. And I'm going to continue this in the next video, actually.